Alright, so the exponents review, okay, this is the notes. Now, don't worry, tomorrow is not the test for your for the exponents. Okay, your test will not be until Thursday. Alright, but we still need to go ahead and get these knocked out. So, number 1. Now, if you remember correctly, this is multiplying. We have multiplication. So what we need to do is we need to actually add the exponents. So what this is that's going to be 7 to the 4 plus 6, which that's going to be 7 to the 10. Number 2 is going to be very similar. If you notice, right here we have a y term, or a y set, a y, and then a z. If you remember correctly, we can only combine the exponents for things that have the same base. Now, y's are our base here, z is the base there. So what we can do is we can add the y exponent, 6 to the 5 plus y to the 6 plus 5, and then the z has to stay alone. And what we're left with is y to the 11, z to the 3rd. Number 3. Very similar to the multiplication version of this, we have division. Only difference is that we are going to subtract. And if you remember correctly, we go from top to bottom. So what that is that's going to be v to the 6 minus 2. And what that kicks out for us is going to be v to the 4. And those are just that simple. Same thing goes for if we have just a variable. This x, we're going to go x to the 2 minus 4, which is equivalent to x to the negative 2, which we don't like having these negative exponents. So what we have to do is we have to say 1 over x squared. And that's our final answer. Number 5. Notice how we have this negative 3 right here. Alright, we're not going to just throw this into the calculator. What I need to see is y'all go 1 over 3 to the 3rd equals 1 over 27. I need to see this step right here to let me know that you understand that that is supposed to be 3 to the 3rd under 1. Okay? Just that simple. Now, number 6. If we look at it, again, we have this negative number here, that negative exponent. And when we have that negative exponent, we have to throw it into a fraction. So, that's going to be 1 over y to the 4th. And that problem's finished. Now, number 7. If we look at number 7, there's kind of a mismatch of things here. First thing I notice is the w here. W to the 0. Anything to the 0 power, if you remember correctly, is 1. So we can go ahead and get rid of that and replace it with a 1. So that's going to be 2 times 1 times y to the negative 2, z to the 3rd. Now, if you remember correctly, things to the negative power need to go into the denominator. Things with a positive power can stay in the top. So that's all good. So what we can do is we can say 2 to the z to the 3rd, y to the 2nd. And there we have it. There's our answer. Okay. Number 8. Now, if you remember, if we have stuff to the second power, what's going to happen, or if we raise an entire chunk to the second power, like we have here, we're going to send the 2 to that, we're going to send it there, and we're going to send it right there. So, what we have, in all actuality, is negative 2 raised to the second, p raised to the 2 times 2, and then q raised to the 0 times 2. We multiply the exponents. When we raise a power to a power, we multiply the exponents together. And then what we're going to be left with here is going to be 4 p to the 4th q to the 0. And if you remember, we can actually knock off this q to the 0, and that's going to be a 1. So our final output would be 4p to the 4th. And there's your answer. There we go. Alright, so, number 9. What we got to do here is we've got the same situation. We're going to take our 5 right here, send it to the x portion, and then we're going to send it to the y portion, and that's going to give us x to the 3 times 5. Let's do that in blue like I already have it. There we go. So x to the 3 times 5, and then we're going to have y to the 2 times 5. And what that's going to give us as our final kick out here, we're going to have x to the 15th, y to the 10th. And that problem is finished. That's all there is to these. Just simple multiplication and addition. Alright, now, on to number 10. Alright, number 10. If we have, say, a to the 5th, b to the negative 2, b to the negative 6, d to the 2nd, things that stand out to me. I've got the same base right here between the b's. Now, the a to the 5th can stay the same. We know that. And what I like to actually do with stuff like that is I like to circle it, and I know those are going to stay right where they're at. So I can go ahead and write down an a to the 5th here, and this is going to be part of my answer, and then a d to the 2nd there. Over here, I like to do my work. So I go b to the negative 2 minus negative 6, and that is going to give me b to the, let's see, negative 2 plus 6 is going to be 4. So that's b to the 4th. Positive number goes in the top, so b to the 4th. So I have b to the 4th, and what I really want to have is, let's see if I can get my 4 to work. There we go. Alright, so what I have as my final kick out here, I'm going to go ahead and rewrite this nice and pretty for y'all. So we got a to the 5th, b to the 4th, all over d to the 2nd. And there's our answer. Okay? Not too bad there. Now, number 11. On number 11, what we're going to be looking for is we got these numbers at the front. We can go ahead and take care of those. Those are pretty simple. So we go negative 2 times 3. That's going to be negative 6. Alright, if we can remember correctly, we can add our exponents. So that's what we're going to do. We're going to add the exponents for the x. And that's going to be x to the 3 plus negative 2. And then we've got the y's that we can add together, and that's going to be y to the 7 plus 1. Final output is going to be negative 6 x, because 3 plus negative 2 is going to be positive 1. And then 7 plus 1 is going to be 8, so that's y to the 8th. Next problem. If you notice, we have z to the 0. And if you remember correctly, anything raised to the 0 is going to just be plain 1. So the final answer for this is x y to the 3rd times 1, which is just x y to the 3rd. And that problem is finished. Just that quick. Number 13. There's some tricks and stuff, and some people do this a little bit differently, but what I like to do is when I see those numbers on the front, I like to go ahead and reduce that. That's 3 over 12, which that's going to give me 1 over 4. And what I like to do is I like to go ahead and take this line, this division bar, go ahead and extend it out a little bit, because I know I'm going to have something involving x's and y's, and I'll figure that out as I go. So what I'm going to do now is I'm going to go x to the 7 minus 2, which is going to give me x to the 5th, and then I'm going to go ahead and do y to the 2nd minus 2, and that's going to give me y to the 0. Now, we already know that multiplying anything by 1 isn't going to do much for us, so we can just drop that act. And we have this left, which is going to be in the top because that exponent is positive. So if we want to rewrite this and make it look a little bit neater, what we can say is x to the 5th over 4. And that's the final answer right there. That's it. Now, number 14. What we have is 3 times a to the 4th b to the negative 3rd times negative 8a times b to the 8th. So what we can do is we can multiply the 3 and the negative 8. That's going to give us negative 24. And then we can do the a's together, and that's going to give us a to the 4 plus 1. And then we can take care of the b's, which is going to be b to the negative 3 plus 8. We're going to wind up with negative 24, a to the 5th, b to the 5th. And there we have it. Now, the next thing that we need to talk about are these powers, these roots. Okay? Now, something that we can do on number 15, there's a couple routes that we can take here. We can go 8, the third root of 8, we can actually plug it into the calculator. The other possibility is to say 8 to the 1/3 power. Either way that you go, it winds up working. Sometimes using the exponent will actually help a little bit better. So, either way you cut it though, you still wind up with 2 being the correct answer for that one. Number 16. Very similar problem. That's just 2187 raised to the 1/7 power. And when we do that, we wind up getting 3. Okay, there's also a way to actually plug this into your calculators. Okay, as in just put in the cubic root or a 7th root, and it's very simple. You should be able to figure it out without any kind of an issue. Now, number 17. Number 17, we've got 32 raised to the 1/5 power. Put that in your calculator. You should pull out 2. And then number 18, when you raise 64 to the 7/3 power, what you should get is 16,384. All right. Now, number 19. Okay. What we have here is we need to go ahead and do what we've been doing with these exponents, the power to a power rule. I know it's a fraction, but it's not that hard. What we do is we take the 1/2, we're going to send it to the 81, we're going to send it to the x, and we're going to send it to the y. So that's going to be 81 raised to the 1/2 power. That's going to be x raised to the 4 times 1/2 power. And it's going to be y raised to the 6 times 1/2 power. Now, 81 raised to the 1/2 power is really simple. All that's going to be is 9. And then x to the 4 times 1/2. 4 times 1/2 is 2. So we got x squared. And then y raised to the 6 times 1/2. 6 times 1/2 is 3. So we got 9x squared, y to the 3rd. And that's the final answer there. Now, number 20. Number 20. This is where being able to convert between the exponent and the root is going to come in real handy. So what we can do is we can actually turn this into an exponent. And how we do that is we say 27 x to the 6th, y to the 9th, all that raised to the 1/3 power. Alright, now we're going to send this 1/3 power to everything. We're going to take it, send it to the 27, we're going to send it to the 6, and we're going to send it to the 9 there. And what that's going to wind up doing for us is that's going to give us 27 raised to the 1/3 power is 3. X, that's going to be 6 times 1/3. 1/3 of 6 is 2, so that's going to be x to the 2nd. And 1/3 of 9 is 3, so we got 1 raised to the 3rd. Or not 1, we got y raised to the 3rd. My fault. Alright, next one. We've got 2,401 times x to the 12th times y to the 4th. All that raised to the 3/4 power. Now, what we're going to do is we're going to do the exact same thing that we've been doing. And we're going to take this 3/4 and we're going to send that exponent to everything inside of these parentheses. So 3/4 goes to that, and goes to that. So 2,401 raised to the 3/4 power, 2,401 raised to the 3/4. This is one that I don't know off the top of my head, but 2,401 raised to the 3/4 power is going to be 343. Y'all can check that in your calculators if you need to. And then 12 times 3/4 is going to be 9. And 3/4 of 4 is going to be 3. And there's our answer. Alright, and again, on number 22, as you can see, this is one of those where having the ability to switch between exponent and root is going to come in handy. So what we're going to have is 81 x squared raised to the 1/2 power. And what we're going to do is we're going to send that 1/2 to both parties in here. So we're going to send that 1/2 to the 81, and we're going to send it to the x squared. And what that's going to give us is that's going to be 9x. And there's our answer. Alright, down to the last 3 problems. All of them are word problems. So let's go ahead and get through these. The area of a rectangle is 72t squared u with a length of 4tu. Find the width of the rectangle. Now, as soon as I see rectangle, I go ahead and I draw myself a rectangle. Next thing that I do is I go ahead and I put the appropriate dimensions in their rightful spots. So we have the area, which is this spot inside. So we're going to go ahead and call that 72 t squared u inside. And then we have 4 tu as the length. We're looking for the width, so we don't know what that one is out there. But it's pretty easy to figure out. What we can do is we can say A equals length times width. We already know that. That is the area of a rectangle. Now we're looking to get the width by itself. So what we can do is we can divide each side of this by L, and that will give us A over L equals W. We already know what L is. L is this thing right here. A is this right here. So what we do at this point is we go 72 t squared u over 4 tu and figure out what that equals. And when we do this, 72 divided by 4 is going to be 18. T to the second minus 1, u to the 1 minus 1. There we go, 1 minus 1. Now what we're left with is 18t, and then the u turns to a 1, so that goes away. So we're left with 18t. Moving along here. The volume of a cube can be found by using the formula V equals s cubed, where s is the length of the side. Find the volume of the cube if each side is 2a to the 4th b squared. So again, I like drawing pictures for everything. So I draw my little cube. And one of these sides is going to be 2a to the 4th b squared. Now, if you remember, the area, or the volume of this, is going to be s cubed. This right here equals s. So we can take this, plug it in to this, and be set. So what we do is we do 2a to the 4th b squared raised to the 3rd. And if you remember correctly, at this point we can go like that, send it to that, and send it here. So what we have is 2 to the 3rd, a to the 4 times 3, b to the 2 times 3, which is going to equal 8. Give myself a little more room here. 8a to the 12th, b to the 6th. And it's done. Last question. Find the volume of the rectangular prism with dimensions 3x squared, 5x cubed, and 7x to the 4th. So what we can do is go ahead and label our picture. 3x squared, 5x cubed, 7x to the 4th. Notice how I just they almost seem random in their location, and that's just fine. You can call that length, width, height. You could say length, width, height. You could say whichever one you want. It can go wherever you want it to, just so long as each one gets one of the dimensions. Now, if you remember correctly, the volume of a rectangular prism is something kind of like that, right? LWH, length times width times height. So what we're going to do is we're going to go V equals 3x squared times 5x cubed times 7x to the 4th. So what this is going to do is this is going to be 3 times 5 times 7 times x to the 2 plus 3 plus 4. And our final kick out on this one should be 15 times 7, which is going to be, let's see, 105. X to the 2 plus 3 is 5. 5 plus 4 is 9. 105 x to the 9th. And that's what goes right here in the slot. And y'all are officially reviewed.